Hello, my name is Kobe, and this is the demonstration of Identifying Robot for Team 5. First, I'll be using manual mode to simulate how the robot behaves autonomously. By entering commands to the terminal, I can trigger each part of the robot's decision-making process so you can clearly see how it handles movement, headlights, obstacles, bystanders, waste, debris, battery levels, and area scan events. After showing each behavior manually, I'll switch into autonomous mode to demonstrate the full algorithm running on its own. To start, I'll demonstrate the basic movement commands. These commands directly control the motors and represent the same navigation behaviors a robot uses autonomously. First, we'll begin with forward. Next will be left, followed by right, and then finally stop. These commands let me manually walk through the robot's navigation logic. Next, I'll demonstrate the headlights. In autonomous mode, the robot turns them on automatically at night and off during the day. I manually toggle them to show that behavior. As you can see, the red lights simulating that the headlights have turned on. And now it's simulating headlights have turned off. Before demonstrating waste and debris detection, I want to note how the camera is handled in this simulation. Since Tinkercad doesn't support camera modules, I'm using a digital IR sensor to represent the camera's output. The IR sensors give a high signal for waste and low signal for debris, allowing me to show the full classification logic from the flowchart. First, we'll begin with waste detection. The robot stops, turns on the green LED, and sends coordinates to the collection robot. Next, we'll do debris detection. The robot stops, turns on the LED, and ignores the object. Next, we'll simulate obstacle detection. The robot performs an avoidance maneuver. Next, we'll simulate bystander detection. The robot stops for safety, waits, and then resumes. Next, we'll simulate low battery. The robot navigates to the dock and begins charging. Next, we'll simulate an area fully scanned. The robot reports that the area has been fully scanned. These manual triggers match the exact flowchart logic. Before switching into autonomous mode, I want to highlight how the flowchart matches the algorithm in the code. The flowchart is built around a continuous loop, and the code follows that same structure. Every cycle, the robot checks conditions in the same priority order: battery level, bystander detection, obstacle detection, normal scanning, object classification, and area scan completion. Each branch returns to the main loop just like the flowchart. Now I'll switch the robot into autonomous mode. In autonomous mode, the robot continually navigates, checks sensors, classifies objects, manages its battery, updates headlights, and performs area scan logic automatically. To finish the demonstration, I'll scroll through the full code so you can see the motor control logic, sensor handling, classification system, simulation overrides, battery management, and the complete autonomous decision-making loop. This concludes the demonstration of Identifying Robot for Team 5. Thank you for watching.